of a very tiny particles, and these particles are nothing but an atom. Okay, so these atoms are smallest particles. Before many years, scientists used to say that these atoms can't be divided, but later on, when study progressed, it is proved that the atoms can be subdivided. And as we have seen, atoms can be subdivided into subatomic particles such as protons, electrons, and neutrons. These are the subatomic particles. They are called subatomic particles because they are present inside the atom. As we know that inside the atom there are two things. There is a nucleus, and there is a around the nucleus there is a orbit in which some subatomic particles are present. So inside the nucleus there are two particles, that is neutrons and protons, where neutrons are chargeless. There is no charge on the neutrons, whereas the protons are positively charged particles. And around this nucleus there is you know there is orbit, or we can say energy levels, in which the electrons are moving. So these are three particles, subatomic particles present in the atom. These atoms are um, present in different forms. These atoms are present in different forms. Like, it is not like different substances are there. As we know, the matter is actually a substance. There is substance around us. So these substances actually divided into two parts. First is elements, and the second is compounds. Now, elements are having only one type of atom. As we have studied last year, there are 118 elements till now discovered. Till now, we have discovered 118 elements, and we have seen that they are placed in the periodic table. So all these 118 elements, they have only one type of, like, if you take example of here, this aluminium. So aluminium, all the atoms of aluminiums are identical. They are all same. If you take sulfur, all the atoms of sulfur are same. If you take copper, all the atoms present in that copper wire are same. If you take bromine, all the atoms present in the bromine are same. All the atoms present in the chlorine are same. All the atoms present in the iron nail are also same. So elements, substance, which are divided into two parts, that is elements and compounds, where elements are the substances which are considered as a pure substances and having only one type of atom. On the other hand, second type of substance, that is compound, which is having different types of atoms. It means that compounds are formed by the combination of atoms. For example, if you take here, before going to compounds, let's first of all concentrate on the this one, elements. Now if you see here, these 118 elements, they are represented by some chemical symbols. They are called as symbols. Every time we can't write the name of elements in the chemical reactions, so to make the work easy, the scientists have made some symbols to represent those elements. For example, here aluminum is there. So aluminum is denoted by symbol Al. Argon is there. Argon is denoted by symbol Ar. And if you see, gold is there. Gold is represented by symbol Au. Now you will say, sir, aluminum is Al, argon is Ar. That's the initial of these elements name. But why gold is starting with Au? Actually, some of the elements, they are given a symbol on the basis of Latin names. For example, now gold's Latin name is aurum. What? Gold's Latin name is aurum. So the symbol of gold is Au, which is taken from its Latin name, that is Aurum. Au. Its Aurum's spelling is Aurum. So the Au comes from the Aurum, which is Latin name of the gold. So here if you can see, iodine is I, symbol of iodine is I, symbol of iron is Fe. Now why symbol of iron is Fe? Because iron is, its Latin name is ferrum. In Latin language, iron is called as ferrum, so it's called as Fe. Its symbol is Fe. So similarly, you can see other elements are there. It's their symbol. If you see bromine Br, calcium Ca, carbon C, chlorine Cl, cobalt Co, copper Cu, fluorine F. So like that, 118 elements. They are all having a chemical symbols. Then there are